Hello, respected teachers. Myself, Aman Singh,
Myself, Yuvraj Kumar Singh.
are here to present our AI Capstone project on wildlife monitoring. Project description. The AI-based wildlife monitoring system uses artificial intelligence to detect and identify animals from images or videos captured in forest areas. The system automatically recognizes different wildlife species and monitors their movement without disturbing their natural habitat. This helps forest officials and researchers track animals, protect endangered species, and prevent illegal activities like poaching. The project highlights the use of AI in wildlife conservation by making monitoring more efficient, accurate, and safe. Problem scoping. Wildlife monitoring using traditional methods is difficult, time consuming, and requires extensive human effort. Large forest areas are hard to supervise continuously, and manual monitoring may disturb animals or put human lives at risk. There is a need for an automated system that can efficiently monitor wildlife, track animal movement, and help in protecting endangered species using artificial intelligence. Problem statement. Traditional wildlife monitoring methods rely on manual observation and patrolling, which are time consuming, inefficient, and limited in covering large forest areas. These methods often fail to provide real time information about animal movement and illegal activities such as poaching. Therefore, there is a need for an AI based system that can automatically monitor wildlife, identify animal species, and support effective conservation and protection efforts. Problems faced. Manual wildlife monitoring is time consuming and requires a lot of human effort. Large and remote forest areas are difficult to monitor continuously. Delay in detecting animal movement and illegal activities like poaching. Risk to human safety during forest patrolling. Inaccurate or insufficient data collected through traditional methods. 4 Ws of AI. Who? Stakeholders, forest officials, and wildlife conservation authorities. What? Problem. Difficulty in monitoring wildlife using manual methods. Where? Context. Forests, wildlife sanctuaries, and national parks. Why? Purpose. To protect endangered species. Data acquisition. Images and videos of animals are collected using camera traps and surveillance cameras placed in forest areas. Additional data can be obtained from publicly available wildlife image data sets. The collected data includes different animal species in various lighting and environmental conditions. This data is used to train the AI model to accurately detect and identify animals. Data exploration. During data exploration, the collected images and videos are analyzed to understand their quality and context. The data is examined to identify different animal species and observe variations in size, shape, and surroundings. Unclear or duplicate images are produced to improve the data set. This step helps in understanding patterns in the data and prepares it for effective training of the AI model. Brainstorming. 4 steps to effective creative brainstorming. Define the problem clearly. Understand the goal or challenge before starting. A clear problem helps focus ideas and avoids confusion. Encourage all ideas. Allow everyone to share ideas freely, no matter how unusual. Quantity is more important than quality at this stage. Build and combine ideas. Discuss, expand, and connect different ideas. Sometimes combining ideas creates innovative solutions. Evaluate and refine. Review all ideas, select and most feasible ones, and refine them into practical solutions. Now, my teammate will continue forward this project.
Brainstorming ideas. AI-based wildlife monitoring. Smart camera traps. AI enables camera in urban green spaces or city outskirts to detect animals. Species recognition. AI model to identify different urban wildlife like birds, squirrel, stray dogs, and cats. Animal movement tracking. Monitor migration or movement pattern to prevent road accidents involving animals. Alert system. Notify city officials or citizens when animals enter human populated areas. Data analysis for conservation. Use AI to study population trends and behavior of urban wildlife. Design. The AI-based wildlife monitoring system is designed to automatically detect, identify, and track animals in their natural habitat. The design consists of following components: data collection layer, camera traps and surveillance camera placed in forest or urban green areas capture images and videos of wildlife. Data processing layer. Collected data is processed to remove noise, duplicates, and unclear images. AI model layer. A machine learning model, example CNN, convolutional neural network, is trained to detect and classify different animal species. Monitoring and alert layer. The system record animal movement and can send alerts to forest officials or city authorities if needed. Rule-based approach uses predefined rules to detect and classify animals. Example rules: four legs plus fur, mammal; beaks plus beak, bird; movement at night, night alerts. Advantages: easy to implement and decisions are clear. Limitations: not flexible for new or unexpected situations, less suitable for large datasets. Learning based approach. Key point: AI learns pattern from data instead of following fixed rules. Trains model like CNN on images, videos of animals for detection and classification. Can recognize animals in new or complex environments. Can detect unusual behavior or movement patterns. Advantages: flexible, handles large datasets, adapts to new situations. Limitations: needs lot of label data and high computing resources. Prototype. The prototype of AI-based wildlife monitoring system demonstrated how the system will work in real time. It consists of camera setup. Smart cameras or camera traps capture image and video of animals in forest or urban green areas. Data processing. The capture data is processed to remove noise and low quality images. AI model. A trained machine learning model (CNN) detects as and classifies different animal species automatically. Monitoring and alerts. The system logs animal sighting and sends alert to authorities if animals enter a human populated area or if unusual activity is detected. Data storage. All information is stored for further analysis of population trends, behavior patterns, and conservation planning. Tools. Programming language: Python for AI and data processing. AI or ML libraries: TensorFlow, Keras for building deep learning models. OpenCV for image and video processing. Dataset: camera trap images, wildlife dataset from public sources. Hardware: camera traps or surveillance cameras. Computer with good processing power. CPU, GPU. Database: SQLite, MySQL for storing animal sighting and movement data. Visualization tools: Matplotlib, Seaborn for analysis and plotting data. Features: automatic animal detection, identifies animals in images or videos without human intervention. Species classification, recognizes different animals species accurately. Real-time monitoring, tracks animal movement and activity in real time. Alert and notification, sends alerts to authorities if animal enter human populated area or unusual activity is detected. Data storage and analysis, stores sightings and movements for research and conservation planning. Non-intrusive, monitor wildlife without disturbing their natural habitat. Supports conservation efforts, help protect endangered species and prevent poaching. Testing report, tested with image and videos from camera traps. Animals detected and classified accurately in most cases. Alerts generated correctly when animal entered in human areas. Data successfully stored for analysis. Accuracy slightly lower in low light conditions. Future upgrades. Real-time monitoring. Integrate live video streaming for instant detection of animals. Drone integration. Use drone to monitor large or inaccessible areas. Mobile alerts. Develop a mobile app to notify authorities and citizens about wildlife sighting. Enhanced AI model. Use advanced AI to detect more species and unusual behaviors. Smart conversation. Combine wildlife and with environmental data, pollutions, greenery for better habitat management.